Good morning, everyone. I am Vinitha, Associate Professor in the Department, RMD Engineering College. Today I am going to explain the types of transients in power system. So depends upon various factors that transients are classified into different types. The first one is based on their origin. The transients are classified into two types. So the first classification is atmospheric origin, that is example lightning. Second one is switching origin. Example is nothing but switching operations. So atmospheric origin is nothing but during lightning condition, there will be a sudden change in voltages and current occurs, and that will be termed as external transient. Second one is switching operations. So during any opening and closing of the circuit breaker contacts or any other switches, there may be a change in voltage or current that may be termed in switching transients. This is otherwise called as internal transient. This is the first classification, which is depends upon the origin of the transients. The second classification, which is based on the mode of generation of transient. In this, the transients are classified into two types, electromagnetic transients and the second type is electromechanical transient. Let us see what is meant by electromagnetic transient and what is meant by electromechanical transient. So first, electromagnetic transients. So we know that the transients are created in power system due to the presence of inductance and capacitance in the circuit. And due to the presence of electromagnet, that is inductance, the electromagnetic transients will be created. And these electromagnetic transients, that is nothing but the changes in voltage and currents which is caused by the opening and closing of circuit breakers or any other power electronic components or any equipment failure or any other faults, lightning strokes, etc. These are the examples of electromagnetic transients. Similarly, the electromechanical transients are created due to the effect of inductance, capacitance, as well as the mechanical parts in the power system. Here, the definition is given. The transients are caused by the mismatch between power production and consumption, causing the generator to either speed up or slow down compared to its normal rotation speed. That is, for example, if the speed of the turbine, which is suddenly reduced or suddenly increased, what may happen? It may affect the input side or the output side, depends upon the input to the turbine. So that may increase the speed of the generator or that may reduce the speed of the generator. So this is the main factor for the faults occur in power system. This is termed as electromechanical transient. So this is the second type of transient. The third type of classification is based on the frequency group. Here, uh, there are different conditions and the corresponding frequencies are given. The first type is nothing but lightning surges. So during lightning surges, the range of the frequency which lies between 10 kilohertz to 3 kilohertz. Similarly, restrikes and disconnectors and fault in gas insulated substation. So if you take the gas insulated substation, whenever the circuit breakers are opening due to capacitance in the circuit, restriking occurs. So during that condition, the range of the frequency lies between 100 kilohertz to 50 megahertz. And then multiple restrikes in circuit breaker. So this multiple restrikes that will be produced due to the presence of capacitance in the circuit. And this is here during this restrike, the frequency that exists between 10 kilohertz to 1 megahertz. And the fourth type is nothing but transient overvoltage. So during this transient overvoltages, the frequency that may lie between 50 hertz to 20 or 100 kilohertz. Depends upon whether the fault is a terminal fault or the short line fault. And the fifth one is fault clearing. So during fault clearing, the range of frequency that exists is nothing but 50 to 60 hertz to 3 kilohertz. And during fault initiation, 50 or 60 hertz to 20 kilohertz. And during fault energization, the frequency ranges 50 to 50 bar 60 hertz to 3 kilohertz. And while low rejection, their available frequency range is 0.1 Hz to 3 kilohertz. And during transformer energization, it is nothing but 0.1 Hz to 1 kilohertz. And for ferroresonance condition, 0.1 Hz to 1 kilohertz. So during various faulty conditions, here the corresponding frequency ranges are given. So depends upon the frequency range and the faulty condition, here the transients are classified. And next one, classification of transients on frequency ranges. So depends upon the frequency range, here the transients are classified. So the first classification, that is the first frequency is 0.1 Hz to 3 kilohertz. And here the shape of the frequency, that is the shape of the waveform is nothing but it is nothing but low frequency oscillations, and this is due to temporary over voltages. And for example, we can say lightning over voltage. This may available only for a short duration. And then the second one is 50 to 60 hertz to 20 kilohertz. And here it is termed as slow front surges. And this low front surges, it is mainly due to switching over voltages. And the third one, 10 kilohertz to 3 megahertz. So it is termed as fast front surges. That is in the lightning waveform, that is in the transient waveform, we have actually two portions. One is nothing but the rise time and the fall time. So the first half of the waveform, that will be called as front surges, and the second portion of the waveform, which is called as the tail surges. So for the switching over voltages, the rise in voltage, that will be in the form of very slow manner. But in the lightning over voltages, the magnitude of the voltage that may increases in a faster manner. So that here the surges that may be termed as fast front surges. That is the first half. That is from 0 to maximum value. That is called as front surges. Okay. So for lightning over voltages, the duration that will be very less, but the magnitude of the transients that will be very fast. And the fourth one is 100 kilohertz to 5 megahertz. This is termed as very fast front surges, and this will produce during restriking of over voltages in gas insulated substations. The next type of transients, which is classified on the shape of the waveform. So depends upon the presence or the shape of the waveform, which is classified into two types. The first one is impulsive type of waveform. So the impulsive type, which is nothing but is a sudden non-power frequency event in which the steady state condition of voltage, current, or both changes suddenly. And the example for this impulsive transients are lightning and electrostatic discharge. And these type of transients, which may be damped out by providing the resistance switching in the circuit. So just now I told that it is nothing but a non-power frequency event, and that may exist in any one polarity. Either it is in the negative polarity or it may be available in the positive polarity. And the change in unidirectional waveform is either positive or negative. So here I have given one example. In this waveform, the wave that is available in the fourth quadrant. So here the current value that will be in negative. So here the impulsive transients, which is characterized by their rise time as well as the fall time. And here from this waveform, we can say that the maximum amplitude of the transient current, which is of 23 kiloamps. Here you can see, here this is minus 20 and this is approximately minus 23 kiloamps. Okay. And the time of transients is nothing but less than 10 microseconds. Here you can see here for this here this is the maximum current amplitude at this period. The time duration is nothing but 10 microseconds. It is approximately time 10 microseconds. So what is impulsive waveform? The waveform that is available in any one polarity, either positive direction or in negative direction, that will be termed as impulsive waveform. This impulsive waveform, which may be classified into three types. First one, that is depends upon the time period. First one is nanosecond. Its rise time is 5 nanosecond, and the duration of this waveform, which is less than 50 nanoseconds. And the second one is microsecond. The rise time for this transients is 1 microsecond, and the duration for this waveform is 50 nanosecond to 1 millisecond. And the third one depends upon, that is the time period is in millisecond. So the rise time for this waveform is 0.1 millisecond, and it may exist for more than 1 millisecond. This is about impulsive waveform. The second type of waveform, second type of transients depends upon the shape is nothing but oscillatory waveform. So if you see the definition for this oscillatory waveform, is a sudden non-power frequency event in which the steady state condition of voltage, current, or both changes polarity rapidly. That is, it is nothing but a bidirectional waveform. So in the previous one, impulsive waveform, I told that the waveform is unidirectional. But for this oscillatory, so oscillatory means which will oscillate in positive as well as in the negative direction. So this is called as oscillatory transients. And this oscillatory transients which may occur due to the resonances during the switching condition. And the frequency for this oscillatory transients may exist from few kilohertz to several megahertz. And here the example for this oscillatory transient is given. And here the circuit, that is the source which is connected to the load side. And in between we have the transformers, bus bars, transmission lines, etc. For this switch, for the system, during switching of shunt capacitors, here the waveforms are given here. If you see this waveform, here the voltage value that starts from 0 and that may increases to positive cycle, and again it comes in the negative cycle also. Similarly, in the second one also, first one it may increases to positive cycle, again it may decreases to negative cycle. And in the first waveform, it's the magnitude of the voltage which is in 1.5 per unit. Maximum of voltage is 1.5 per unit. And in the second case, the maximum of voltage is nothing but 2.5 to 3. And here, this type of oscillatory transient, which is again classified, depends upon the frequency, range of frequency. First one is low frequency. The available frequency is less than 5 kilohertz, and the duration is 0.3 to 50 millisecond. And here, the value of the there is the magnitude of the voltage available is 0 to 4 per unit. And the second classification, medium frequency. The frequency range is 5 to 500 kilohertz, and the duration for this transient is 20 microseconds. And the voltage available during this period is 0 to 0.8 per unit. Third one is high frequency, that is from 0.5 to 5 megahertz. And the duration for this transient is 5 microseconds. And the voltage available during this period is 0 to 4 per unit. And next one depends upon the speed of the transients. The transients is classified into 3 types: ultra fast transients, medium fast transients, and slow transient. So ultra fast, the speed of the transients that will be very, very high. So for example, we can say lightning transients. And the second one, medium fast transients. So the speed of this transients that will be lesser than ultra fast transients. And these transients may occur due to abrupt short circuit in the system, causing abnormal structural changes in the system. Okay. And the third type of transient is slow transient. So here, comparing to ultra fast and medium fast transient, this type of transient, that is the duration of the transient, that will be very, very low. And these transients, which may be created due to the due to any electromechanical failure in the system. Next one is type of transients, that is classification of transients. Depends on the control on transients. It is classified into 3 types: single transient, recurrent transient, and random transient. So what is meant by single transient? Single transient is nothing but the transient that is created by opening and closing of the switches. This is depends upon the switch, the operators, whoever operating the switches. So we know while operating the switch, we know when the switch gets open and closed, what are all the consequences while opening and closing the switches. Okay, so that we need to we know when these transients occur, and we have to provide the solution for these transients. And the second transient, recurrent transient. So these recurrent transients is nothing but it is an regular transient. That is, the occurrence of transients is very frequent, and this is occurred in while commutating for any converting equipments like any power electronic components and whatever may be. All those system we will be using the switches. So during that time, what will happen? The recurrent transient that may be produced. And the last type of transient, that is called as random transient. So these transients that may be generated by extraneous operation, that is without any symptom, or without, that is unexpected condition. If the transients are generated, and that transient that will be termed as random transient. These transients are created beyond our control, so which appear in unpredictable random manner. So that's why it is called as random transients. So these are all the type of transients, depends upon various factors. Thank you.